Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 9. Today we're going to learn about reinforcement learning in machine learning. Okay, let's begin with starting simple topic and then we discuss about the states and actions. So, reinforcement learning. Reinforcement learning model is a branch of machine learning that focuses on the how agents can learn to make decisions through trials and errors to maximize the cumulative rewards. RLA allows the machine to the learn by interacting with an environment and the receiving feedback based on the actions. This feedback comes in the form of rewards or penalties. Okay, so here we discuss about reinforcement learning is a type of machine learning where the agents learn to the make decisions. Okay, learn to make decisions by interacting with environment. So the goal of an agent is to maximize its cumulative rewards over time. So here we can say agent, the entire state. So we can say here we have interpreter and we have reward and state and action and environment, right? So here the agent, the entity that learns and makes the entity that learns and makes decisions. Think of it as AI program. Okay. So here the environment is nothing but the world, like we can say that the world of context in the which a agent operates. That could be a game or physical robot surrounding a stock market or anything analysis. So trials and errors will be the agents learn from the defiance and past mistakes. So the environment it does not have a predefined set of instructions to explore the find in the work. So the reward we have the feedback here. So in reward, let's reward the goal that agents is not just trying to get the rewards, is trying to minimize or maximize the total reward it receives the overlap or the over a long period. This often involves balancing immediately rewards within the potential long-term benefits. So feedback. So it is also a penalty or reward. So this is how the agent learn after taking an action. The environment provides feedback in the form of rewards, okay, or a penalty, or in a negative reinforcement. So we have positive reinforcement and negative reinforcements. So this agent uses the feedback to adjust the strategy of learn which action or good and the which or bad different solutions. So in simple terms, we can say that reinforcement learning is about to training an AI to achieve a goal by rewarding it for a good behavior and penalize like penaltying its a bad behavior for penaltying its bad behavior. Similar to how a dog trained with tricks and the agent learns from the certain actions with positive outcomes and will try to repeat those actions to get more rewards, right? So reinforcement learning revolves around the idea of the agents. The learn of the decision makings interacts with the environments to achieve a goals. The agent performs actions and receives feedback for optimization, decision making over time. Okay, agent. We have the agent, environment, and state and action, right? So here, what about the agent? About reinforcement learning, the core idea is the agent to learn the interact with an environment to achieve a specific goals, right? So agent is the brain, the decision making, the performance state. Okay, this is the brain of the operation, decision making that observes the environment of an action chosen with an action. So environment, the world or system in the which an agent operates, right? So it is a concept of that the state represented by the current situations or the conditions of the environment at the given moment. So the agent decisions of the what action to take often depends on the current state. So we have the state. This is a crucial concept. So situation according to the state, the condition of the agent is currently in. Okay, the current stage. So action, the possible moves or decision that agent can make. So those are the possible moves or decision to the agent can make within the environment. The agent chooses an action based on its current state and it learned from policies. So comes to final state reward, the feedback or result from the environment based on the agent's action. So this is the feedback from the environment. It is a numerical value, positive or negative, that tells the agent how good you are, how good or bad its last action was. Okay, the agent dot ultimate goal is to learn strategy to maximize the community rewards and collect the rewards and receive over many states and actions. So this process works in a loop. The agent observes the state of the environment, choosing an action. The environment transitions to a new state and gives the agent a reward, and the state the agent uses to reward to learn and make better decisions next time. So this continuous circle observation, actions, and rewards is how an reinforcement learning agents learn. So how reinforcement learning works? Okay. So reinforcement learning involves an agent performing action in an environment receiving rewards. or penalties based on those actions, and adjusting its behavior according to the loops helps the agent improve decision making in an over time, maximizing the cumulative rewards. Okay, here's the breakdown of reinforcement. So we have policy, like we can say the strategy that the agent uses to determine the next action based on the current state, right? So this is the agent strategy. Essentially, it is a set of rules that agent use to decide what action to take. Okay. So reward function, a function that provide a feedback on the actions taken, guiding the agents toward its goals. So the function is a part of an environment. It defines the numerical feedback agent receives after performing an action in a specific state. So value function estimates the future cumulative rewards to the agents will receive from the given stage. So it is a cumulative reward. So long term, a value function estimates the long term of or future cumulative rewards that can be agent can expect to receive starting from a given state is not just a immediate reward of an action, but the total reward of over long sequence of action. For example, a value function might be tell the agent substitutely bad action or good action. So actually like good like that. So model of environment. So a representation of the environment that predicts the future state and the reward aiding in plans. So this is an optional but powerful component. Not all reinforcement learning algorithm use it. So when an agent has a model of environment, it can simulate future states and the rewards without actually taking an action in the real world. This allows to taking agents or actions in the real world. Okay, this allows to agents to plan ahead in the different scenarios. So function first we initializing a queue table, select an action to perform, and perform the selected action, measure the reward, update the queue table like that. Reinforcement learning example navigation, a main state and action. Okay, so this is that we say that. So imagine a robot navigation a maze to reach the diamond well. So for fire hazard. So the goal is to find the optimal path with the least number. Okay, the hazard while maximizing the reward. So each time the robot moves correctly, it receives a reward. If the robot takes any wrong path, it loses the points. So like the reward system, states and actions depends on like this. Okay, the robot learns from exploring the different paths in the maze, but trying to various moves. It evaluates the rewards and the penalties for each path. Over time, the robot determines the best route by selecting an action that lead to a highest cumulative rewards. So, state action describe the four keys variables to position to reach it to the goal state. So we have position, velocity, angle, and angular velocity of the card pole system. So it is a state space. And now comes to the action space. So describe the action either moves to the card left or right. Okay. Reward the agent and 1 point for each step, and the go pole remains the balance. So like this, we can say that. So if the agent, so I start from here. So I come one direction upwards, and then I take rightwards, and then again I take right. If again I take the right, so we can see here, then I take right here, okay? Wait, again in this situation, I get here plus 1 point. Here I get plus 1 point in reward because I am taking the correct sequence state. Here it gives a hold because if I enter in the burner, so I take the wrong path, so it gives a negative one. So it in minus it gives a penalty too. You take the wrong step. So like that, if I move again up and again the right, so again I move to left side. Again I comes to down. Again I get the -1. So I choose a -1. So penalty points. It is you get a penalty. If I take like this, if I take correctly, okay, like this, if I move correctly. So when I reach to here, then I take directly downwards. Okay. Again I take the down. Again from reaching downwards. Again I take downwards and I take the direction to the again right. And then I reach my goal state, right? I reach my goal state, then I get the bonus points. So, like the reinforcement work during the learning, it learns from the past mistakes. Also, we can say that. So, according to it covers all the paths. So, the robot learns process can be summarized as follows. So, exploration: the robot starts by exploring all the possible paths in the maze, taking the different action at the each step. moves left, right, up, or down. Feedback. After each move, the robot receives the feedback from the environment. Okay, you're taking right or you're taking a correct path, you're choosing the wrong path, you get a reward, like complimentary, we can say, in feedbacks, in rewards. So a positive reward moves to the closer to the diamond, and a penalty for moving into the fire hazard. Okay, so adjusting the behavior based on this feedback, the robot adjusts its behavior to maximize the cumulative rewards for favoring paths. Okay, that avoids the hazards and the bringing it closer to the diamond. So optimal path is eventually the robot discovers the optimal path with the least number of the hazards and the highest reward by selecting the right action based on the past experience. So this is the overall behavior. Okay. So this is the applications of reinforcement learning control in game playing and in chemistry, in finance sector, manufacturing sectors, business and robotics and whatnot. And also we use most of the sectors in we used to train the robots or machine by using reinforcement learning. Okay. So I hope you guys all are understand about this topic. Thank you.